Welcome to the Explainer. Today, we're going to break down one of the most exciting advancements in AI right now, autonomous agents. We'll be looking specifically at how they're built using Amazon Bedrock. So let's just start with a question. What if your AI could do more than just talk? What if it could actually understand a complex request, figure out all the steps, and then just do them for you? Yeah, we're talking about moving way beyond simple chatbots to real-deal digital assistants. And that is the core idea behind AI agents, like the ones in Amazon Bedrock. You see, they're designed to understand a big picture goal, and then, all on their own, figure out the specific actions needed to make it happen. Like interacting with other software or pulling data from a database. So let's break down how you actually build one of these things. To really get a handle on this, we're going to structure this explainer around two main phases. We'll kick things off with how you actually build an agent, which, honestly, you can think of it like training a brand new, super specialized assistant for your team. The best way to really understand all the moving parts here is through this analogy. When you're setting up an agent, you're not just, writing code. You're basically giving a digital assistant a brain, a really clear job description, and all the tools it's ever going to need to succeed in its role. Now, what's so cool about this is how it maps all these technical components to a simple, totally understandable structure. This is your agent's resume, right here. You got its brain, its job description, its tools, and its own personal library. Let's dig into each one. Okay, first things first. Every assistant needs a brain. In the world of AI agents, this is the foundation model, or FM. This is the core engine doing all the heavy lifting, all the thinking, all the reasoning, all the planning. And what's really key here is that you get to choose which powerful model, like Claude or Llama, is going to be the brains of your operation. Next up, you give it a job description. This is where you write out in just plain English what the agent's purpose is. Something like, hey, you are an expert travel agent, and you help users find and book flights. These instructions literally guide every single decision the agent makes. But let's be real, an agent that can only think isn't all that useful. It needs tools to actually get work done, and that's where action groups come in. They are its toolbox. They give the agent the power to interact with the outside world by calling APIs. And this is all defined using a standard blueprint called an Open API schema, which is basically an instruction manual the agent reads to understand exactly how to use each tool, whether that's to book a flight, check inventory, or create a customer ticket. And finally, we give our agent its very own private library. Knowledge bases connect the agent to your company's specific private data. This is the magic that lets it answer questions based on your internal documents or product manuals, not just what it can find on the general internet. So once you've assembled all these components, the brain, the job description, the tools, and the library, the agent is ready for phase 2. We're moving from all the setup stuff to seeing it actually take action. And it's really, really important to understand this distinction. Build time is everything we just talked about, all the configuration in the setup. Runtime, well, that's when the agent is live, gets a request from a real user, and just swings into action. Okay, so what is actually happening inside the agent's brain when it gets a request like, find me a flight to Hawaii? Well, it follows this really sophisticated reasoning process that Amazon calls orchestration. Just think of orchestration as the agent's internal thought process, and it's happening in this continuous loop. This right here, this is basically the agent's inner monologue. First, it analyzes what you're asking for. Then it decides which tool to use, like, should I call the flight booking API or should I look up airline policies in my knowledge base? After it takes an action, it gets back a result, which is called an observation. And finally, it looks at that observation and decides, okay, what's next? And this is not a one-and-done kind of thing. The agent might need to call multiple APIs or look up several different documents, looping through this whole cycle again and again. For that flight to Hawaii, it might first call an API to check for seats, get a result back saying none available, and then loop again to check nearby airports, all to accomplish that one single initial goal. Now, the best part is, you're not left in the dark while all this is happening. Amazon Bedrock lets you turn on something called a trace, which is basically a flight recorder for your agent. You can literally see its step-by-step reasoning, which makes it incredibly easy to understand its choices and, debug any issues that crop up. So why is this so powerful? Why does any of this really matter? Well, because it unlocks a completely new level of automation that goes way, way beyond simple scripts or chatbots. This gives you an idea of the potential across a few key areas. I mean, take customer support. We're not just talking about a bot that answers FAQs anymore. An agent can automate an entire return process by itself, actually logging into the shipping provider system to generate a label and then updating your inventory database all from one single request. Or look at sales and marketing. An agent could handle lead qualification by pulling data from your CRM, cross-referencing it with public data, and then drafting a perfectly personalized outreach email. It connects all the dots across all your systems. So the key takeaway here is that we are moving so fast from AI that just gives you information to AI that actually gets things done. This technology isn't just a search engine anymore, it's an action engine. Which really just leaves us with one final thought. What's the first big, messy, complex problem that you would solve with it?